Thanks, Mike. And first of all, thanks to FNFC and PSF for bringing us all together. It's a pretty amazing room of people gathered today. So I feel, frankly, a little bit humbled to be standing in front of you. But I am really excited to share some of the work we've been doing. And the work is really trying to think about how salmon ecosystems are changing, but then also linking that science to action, linking that science to stewardship. So I want to start by taking us underwater. So the salmon journey is unfolding as we sit in this room. So salmon have migrated maybe thousands of kilometers back to the place where they're born. They use their internal GPSs and the smell of their home rivers to find their habitats. They find clean gravel, clean water, they dig, they fight, and then they give everything to the next generation. And so that cycle of death and life is happening as we gather here today. And so as the parents pour their whole life force into the next generation, this is what's now in the gravels. Around the Pacific Rim, in thousands of rivers, there's millions or billions of little tiny salmon eggs that are fertilized, thriving off of the gifts from their mother, and this is the hope for the next generation. This is what's happening as we're gathered today. Isn't that amazing? And so I like to hold that context for as we have these conversations, and I also want to hold this sort of context for the work that we do and the actions forward. This is artwork shared by Lauren Marchand, a silk artist that we had the opportunity to work with for one of our projects, and she was excited for me to share this with you today. And this is a woman walking into the future, and with her, she's carrying threads of salmon and threads of water into this future, walking in the steps of her ancestors. And the reality also is that this landscape that's been stewarded by indigenous peoples for thousands and thousands of years is also a landscape where there's been deep harm. And so as we sort of move forward in a good way, it's important for us to think about those connections, those harms, that healing that needs to happen between salmon and people. So today I'm going to try to talk about two big questions that we think a lot about. That is, how are salmon ecosystems changing? And then, based on that, what do we do about it? In our group, the Salmon Watersheds Lab, we use three main approaches. We intertwine big data analysis, a lot of remote sensing actually, to get that view literally from space. And then we pair that with the muddy boot waders on, working shoulder to shoulder with local experts on the ground in the watersheds in field research. And we also really, try to honor the collaborations and try to bring people together for those connections to try to understand how we think about these things differently and similarly. And I'm really proud of the work we do, and I'm really proud of the team, the amazing group of people over the years, and it's fun to see the sort of generations of folks off and doing their amazing things. And it's supported and made possible by great collaborations and many different sources of support. Okay, so the flow, get it, flow? The flow of this talk is going to be roughly as follows. So we're going to start by talking about rapid change in these complex ecosystems that people and salmon call home. And then I'll share three short vignettes towards climate resilience. How do we understand this ideas of change and then link it to ideas of action? And then I'm going to offer some of my own personal thoughts for paths forward about what I think the science says about what I think we could do. Okay, so let's start about this idea of complex change. So when we think about salmon ecosystems, I do think about them as these complex socio-ecological systems. That's sort of a fancy, jargony way of thinking about the fact that people and water and land are all connected and influence each other. And these are being pressured by these big sources of pressure. Climate change, human-caused climate change, as well as different local activities that are asking a lot of salmon systems. So those are sort of the major pressures on salmon ecosystems. And the reality is that in many places in BC, we're seeing fewer salmon in our rivers and in our nets. And so spawner abundance has decreased. in 70% of assessed stocks across BC, according to a recent report from PSF. Commercial salmon harvests have declined by around 70% over the last several decades. And elders from over 15 First Nations shared that their harvests have declined by over 80% over the last half century in a work led by Dr. Andrea Reed. So what that means is, yeah, there's some systems that are actually thriving, some systems that are also doing okay, and also a lot of systems that are struggling and getting pushed towards impoverishment. So that's the state of the trajectories of salmon systems and why I think we're gathered together today. So what is the science about these pressures? Well, first of all, climate change is happening, and one of the obvious symptoms is the world is getting warmer. Here's some data from across the range of salmon in North America, and what we see is air temperatures are warming, with more rapid warming in the north. Warming air temperatures generally leads to warming water temperatures. Another symptom of climate change is changes in the amount and form of precipitation. In general, dry places are predicted to get drier, so inland places are supposed to get less precipitation, and coastal places are predicted to get more precipitation, so wet places are supposed to get even wetter. And so that's the amount of precipitation, and of course there's a shift in the form too, such that there's going to be a shift from more precip coming down as snow towards more coming down as rain for much of British Columbia. This has impacts on what salmon feel in these ecosystems. Warming water temperatures is a pressure. This will also lead to decreasing summer flows in many places in British Columbia and increasing risks of fall and winter floods. And as we know, salmon are a cool water species. So as water temperatures warm, salmon performance might increase a little bit, but then at some point, they'll start to struggle as the waters get too hot, and at some point they'll actually have heart attacks and die when lethal limits are reached. And so hot waters kill salmon in some rivers and in some years. And climate change is impacting salmon across the life cycle, from the oceans to the freshwaters to estuaries. But as we think about how climate change plays out over this amazing place that we live that has so much diversity, I think we really need to consider how that diversity will modulate and influence the paths forward. So if we think about salmon systems, there's incredible biocultural diversity where different people interact with salmon. Salmon also can thrive in amazingly different habitats. Maybe it's a coastal rainforest shown here, maybe it's an Arctic river, maybe it's a desert. Salmon have a proven track record of being able to thrive across diverse habitats. And they do that through diverse adaptations, right? And so here we have a picture of two sockeye from nearby populations. One looks like it swallowed a dinner plate. The other one is quite shallow, and that shallow-bodied one evolved in a stream that's very also shallow, and there's lots of grizzly bears. So these actually evolved due to grizzly bear predation risk, and that's what drove those body changes. But there's all sorts of amazing adaptations that salmon have across their range to thrive in diverse places. And those are coded by diverse genes. So we can imagine that these different layers of diversity will provide different solutions for the climate change pattern and process, and it will also mean that salmon have a pretty diverse portfolio of options. If we keep these options forward, maybe one of those will be the right puzzle piece for the climate change challenge. To bring that to life a little bit, I want to share some of the work that we've been doing, in particular a little study on the run timing of adult salmon, adult Chinook salmon across their range. And this is the timing of when they enter the river, when they start that migration back upstream to spawn. What Anna Potapova did, a former master's student, is she pored over records of that timing and brought it together across the range of salmon populations from California all the way up to Arctic Alaska, which each blue dot being a different place where she found, okay, the timing of this population comes into this time. And what she found is amazing, right? So what we see is that in the Arctic, some salmon come back when it's warm enough. They come back during the summer. But as you start to go down in latitude, down towards British Columbia, you start to see more run timing diversity. You see more of those spring runs start to appear in our rivers, or more fall runs as well as summer runs. And then you see this really amazing thing start to happen in Oregon and California, where salmon are either coming in late or early. They're either coming in before the hot waters of the summer or after the hot waters of the summer. So I think this really showcases, first of all, that over generations and over time, salmon do have the capacity to adapt to challenging conditions. This is just one example of how there's this amazing diversity, and salmon have found solutions, different solutions, to the challenges that they face in their places. I also think this is incredibly relevant for thinking about climate change and resilience. So if we think about climate change as being a zipper that's going to pull that hot water farther and farther north, what that should do, we predict, is pull those runs farther and farther apart. Early run timing fish should be migrating earlier. Late run timing fish should be migrating later. It's important to think about, can they keep pace? Can the run timing of salmon evolve to get earlier or later fast enough? And the answer is maybe. And so if you do the back of the envelope calculation, it looks like actually it's quite within the realm of possibility, but we do need to give salmon that space and the time to adapt. The second thing that I think is really interesting about this is if we look at where BC is right at that pinchy part of the zipper, right? Right where you gotta watch out for zipping your skin in there. So what's going to happen in BC is it should be the place where those run timings start to get ripped apart right here. We should expect to see divergence. We should expect to see pressure as our waters warm during the summer and as there's selection for earlier or later run timing. So I think understanding this diversity and looking to the future, maybe even looking to the south about what we should be expecting, is particularly important. And if we go back to this idea of diversity, I think this result really shows how, by keeping these pieces of biodiversity, we give the options and the framework for future adaptation. Salmon have this track record of solving problems through adaptation, through local adaptation, but they do need time and they do need space in order for that diversity to be able to adapt that then provides resilience. So how do we do that? How do we give salmon the time and space to cope with the oncoming challenges? So I'm going to share 3 quick vignettes about this idea of towards climate resilience from rivers, estuaries, and glacier systems. So the first story comes from interior of BC. These are working watersheds where there's a lot of industry. Forestry is quite prevalent in many of these systems. And as I mentioned, in some of these rivers, in some years, hot waters can kill salmon because they just are, it's too hot. So with global warming, we're expecting rivers to increase in their temperature further. With low emissions, if we do a good job on working towards decreasing greenhouse gas emissions, then that will happen slower. The systems will get pushed slower towards that cliff. If we don't do a great job, the pressure is going to be fast and hard. But it isn't just climate change that affects warming rivers. So this is a time lapse of an interior BC watershed and forestry practices as they've unfolded over the last 40 years. And this is a system that does contain imperiled populations of salmon and steelhead. And work by our group, as well as many other groups, has repeatedly found that aggressive forestry practices can substantially warm water. Heavy levels of riparian harvest can warm water temperatures upwards of 5 degrees Celsius. That's a lot of climate change equivalence. That's a lot of additional thermal pressure on these ecosystems. So what this means is that if we look at where salmon ecosystems are on this thermal performance curve, if we log them hard, we're going to push them faster off that cliff. On the other hand, if we take a more precautionary principle, if we live bigger riparian buffers, we can actually mitigate some of the oncoming harm of climate change. And we can put this together and ask how different combinations of forestry and climate change will affect the health of salmon ecosystems. This is work led by Marta Ulowski, a great PhD student in our group. And what we see here is results from a massive modeling exercise where we looked at a salmon life cycle, and that salmon life cycle is controlled by its survival. And we know how survival is influenced by temperature. We know how temperatures are influenced by climate change and by forestry. And so we can dial climate change up or down, we can dial forestry up or down, and we can ask, how are salmon doing? And then the heat color is how salmon are doing. So in green, we have a thriving population where the goals are met, the fisheries is occurring and doing great. And that happens if there's low riparian forestry harvest, if things are pretty well protected. This system can actually take a lot of climate change. It looks like it's going to do okay through 2100 under this formulation. On the other hand, as you start to dial up forestry, at some point, and this gets even more vulnerable as climate change unfolds, the first thing to go is the sustainable harvest. The fishery will need to be shut down in order for the salmon numbers to make it back as outlined and as hoped for. The second thing to go as you dial up forestry even more is the numbers of fish returning to the spawning grounds. And then at some point, the combination of climate change and forestry will push this system to the point of extirpation. It will collapse. And we think that this is reasonably true for a given example of an interior sockeye population in interior BC. But frankly, the details don't really matter to me as much as I think the key bottom line. And that is we can either make things worse or better in terms of the trajectory of these systems based on how we steward forestry. And I actually think this is incredibly important and actually probably quite common across different activities that we do in salmon watersheds. I think it's quite common that there's actually these local and global pressures of climate change are pushing the same symptoms that then will harm salmon. So for example, common climate symptoms that we mentioned are warming water temperatures, decreasing summer flows, increasing fall and winter floods that we'd predict in many places in BC. And if we look at some of the major industries, these are the same symptoms. So forestry not only warms water temperatures like we talked about, but in the decades following harvest, summer flows will often be decreased and winter flood risk will increase. Aggressive agriculture shares the same symptoms. I think this is really important. And I think, frankly, I think it raises this really important question of, are environmental regulations that were developed in a climate normal past, are they going to be enough to protect salmon in a climate changed future? I think we need to be asking ourselves that question. And it's also really exciting to talk to people and hear about how different groups are thinking about how they can work differently in their watersheds and whether they can give salmon ecosystems more space so they aren't pushed off these cliffs. So that's the first vignette. The second vignette is from estuaries. So estuaries are these amazing places where rivers meet the sea. They're used by nursery habitats for young salmon. And so the growth of salmon in these places is really important. Some of the work we did in the Quay River in partnership with the Heiltsuk First Nation found that the growth of young coho as they reside in this estuary on the way out to the ocean and just grow like gangbusters, about 10 times faster than in freshwater, that growth translates into an estimated 40% increase in marine survival because they grow big and they can then escape that hungry-mouthed ocean. So estuaries matter to salmon populations. Estuaries are also feeling dual pressures of climate change and local activities. And in particular, there's this idea of coastal squeeze, where as sea levels rise caused by climate change, the ocean will move up slopes, and in some cases, the tidal marshes will adapt with that. They'll just move up the slope, they'll go farther and farther up the coastline. On the other hand, if there's coastal development, that migration will be blocked, and the ecosystem will be increasingly squeezed between those hard walls that we build and the rising ocean. Just to bring this to life with some pictures, here's an estuary on the east coast of Vancouver Island, and you can see that by 2150, according to these projections, sea level rise is going to be about 25 centimeters, 2100 with moderate emissions, 65 centimeters, although if some of those sea ice sheets collapse, 1.3 meters. So there's some change coming. There is rising oceans headed our way. And you can imagine that in the green arrows, well, this estuary might be able to cope with this. The estuary might be able to adapt upslope given the rising ocean. But in the red arrows, that's where that migration is going to be blocked by levees and dikes. So it's been amazing getting a chance to work on this estuary resilience project led by Nature Trust of British Columbia and over a dozen different First Nations, working on Vancouver Island estuaries and Central Coast estuaries, trying to understand the resilience of estuaries to climate change, and then linking that information to proactive restoration. So my team and I work in estuaries like this. This is me trying not to get pulled into the ocean. Phoebe, my grad student, saving me, working shoulder to shoulder with the local experts, learning where salmon use these habitats, and then thinking about how these habitats will shift into the future. And amazing work is being done in this project, associated with this project, such as in the Cowichan, where there's this large restoration project that's being moved forward that would remove dikes and levees and enable this ecosystem to adapt with climate change. So I think this is a really amazing example, a really inspiring example of how by understanding how these ecosystems are changing, we can take action now to help foster resilience, to help give these systems a space or time to change with a changing world. The last vignette I want to share is from glaciers in northern BC and Alaska. So glaciers are these amazing symbols of Canada, and the images are frankly shocking, where you have pictures taken half century ago that used to be ice, and now the glaciers are way up in the mountains. And the projections are hard. 80% of glaciers are predicted to be gone by 2100 under a moderate emissions scenario. And while the loss of glaciers poses vast risks to downstream ecosystems and people and fish, the reality is that salmon are also quite opportunistic species, and they're finding these new habitats that are being created by glacier retreat. So work by Sandy Milner found they're watching this small stream year after year in Glacier Bay, Alaska. The glacier retreated, and then 2 decades later, there was 10,000 salmon in this tiny little creek that was brand new. So my team and I have been doing this. We've been mapping out where and when glacier retreat will create future salmon rivers. This is work led by Dr. Kara Pittman. And so she used glacier forecast models for the 42,000 glaciers across the range of salmon to ask this question. And what we discovered is, not surprisingly, where there's a lot of glaciers, there's going to be more creation of future habitat for salmon. We're predicting over 6,000 kilometers of new salmon rivers by 2100 under a moderate emissions scenario. And I want to be careful here. I'm not saying climate change is good for salmon. This is happening even as climate change is posing amazing harm across their life cycle, across their range. But the reality is that it is a transformation. With transformation comes opportunity, and so we shouldn't ignore those local opportunities that might be mitigating some of these large-scale harms, a portion of them. And so those are the predictions from the models. On the ground, it's even shocking. So it's one of the places we work is the Taku River with Taku River Tlingit First Nation. And picture taken in 2007, up valley in the Tulsuke River system shows, ice, and then a large river draining that ice. And then by 2019, there's an intimidatingly big lake. It's now 2 kilometers from the edges of the ice to the river outflow. The lake's over 200 meters deep. 2007 is when my daughter was born. This is happening now. And standing, looking over these ice fields and talking through the model projections with the local leaders, frankly, it's heartrending to think about the loss of this power and the loss of this beauty. But again, you go just downstream and there's salmon. So in the clear groundwater channels in these complicated floodplains, river-type sockeye are finding and flourishing in these new habitats. But it isn't just salmon that are looking to the retreating edges of glaciers for new opportunities. It's also mining companies. So here's a quote from a mining company. In 8 years of glacier retreat, at the rate it's been going, there could be an ore body sticking right out of the ground that nobody's ever seen before. This region is known as the Golden Triangle, and it's where there's a massive gold rush. So we mapped this out. We looked at where there's future salmon habitat and where mining companies have actually already staked claim on top of that future salmon habitat. And what we found is that of the 114 rivers with future salmon habitat, 25 of them already have much of their habitat near a mining claim. Glaciers, mining companies are staking claims on top of glaciers to get the rights for those minerals in anticipation of their retreat. I think this type of information and this type of thinking is really important. First of all, it's a question that we should be asking ourselves. As the ice retreats, how do we want to be stewarding this place? Do we want to steward it for gold mining, or do we want to steward it for salmon futures? And frankly, it's really inspiring to get a chance to work with some of the nations up there as they declare new indigenous protected conserved areas that are indeed protecting future salmon habitats for future generations and thinking about how these ecosystems change and how we can steward it into this changing world. Okay, so I want to sort of try to bring all this together and think about, as a scientist, what do I think the science says about what the major paths are forward? So first of all, if we bring these ideas together, here's a cartoon that is sort of how I roughly think about it from an incredibly simplistic perspective. We have these dual pressures of climate change and local activities. And these, frankly, we're asking a lot of our salmon watersheds these days. We're asking a lot of them. And these things are pushing these linked systems of people and water and nature all together towards places of either thriving or impoverishment. But by taking action for preservation of diversity, for giving space, that can help these systems adapt and be resilient to these oncoming changes. So what do we actually do? Well, first of all, I think, on a global scale, I do think there is a need for us as salmon peoples to be thinking about climate change and taking action on climate change. Maybe people think about polar bears, maybe people think about coral reefs. Salmon are also on the front lines of climate change, and whether it's local action or pressuring our politicians to take action, climate action will help steward salmon futures. Second, I didn't talk about it that much, but the science is incredibly strong that ocean pressures on the sort of international ocean basin scale are also a major challenge for BC's salmon. Whether it's mixed stock fisheries, such as Alaskan fisheries that harvest BC fish, or international production hatcheries of salmon that now have been associated with more pink salmon in the ocean now than has arguably ever been seen. And we know now that when there's more pink salmon in the ocean, BC salmon productivity declines, their size declines, and they get older. So I think there's a need and opportunity for BC to continue to lean into these really hard international issues, especially leading up to negotiations and renegotiations for the Pacific Salmon Treaty in 2028. Okay, if we move downscale a little bit, I also think we should be thinking about protecting salmon regions, broad swaths of landscape that have functioning watersheds where the ecosystems work, where there's strong salmon biodiversity, and think about how we protect them with people. Protect these places that do have these strong relationships between salmon and people. And whether it's through salmon parks or indigenous protected and conserved areas or other policy levels, I think this could be a real key way to give salmon, to protect the sort of the adaptive capacity of salmon, protect the sort of building blocks for the future. If we go down in scale, there's also the continued need to advance science-based restoration and mitigation, trying to reduce the harms of the various things that we ask of salmon watersheds. I do offer a bit of caution with this one. A recent provocative paper asked this question: why aren't salmon responding to habitat restoration in the Pacific Northwest? And one of the reasons they gave is they said ongoing habitat degradation is offsetting habitat restoration. So I think restoration is incredibly important, but I think we also can't be handing out Band-Aids as we continue to cut up salmon watersheds with the other hand. And the last thing is to continue to try to think about and take action on reducing pressures on current and future salmon habitats. We need to ask less and give more of salmon into this warming world. So these are some of the things that are these paths forward. These are big, hard things, but frankly, this is what these conversations over the next day and a half are about. Many of the sessions are tackling these exact things. So I'm really excited to be digging into these topics and thinking about what can we do for this generation of salmon that's in the gravel right now as we speak, and how do we steward their futures. And frankly, we do hold salmon in our hands. Their future is in our hands. And I look around the room and I just want to thank you for all the work that you do now, and thank you for the work that you're going to do in the future, because this is the trajectory that we share. Thank you.
Thanks, man. That was great, Jonathan.
Thanks.